Yesterday we took a look at how John Dalton used some measured data, some percent composition values, to come up with relative mass values for different elements as they combined to oxygen in his efforts to come up with the first set of molar masses for our elements. Today we're going to continue on that idea of counting by weighing and looking at relative mass. So, in the room on the front table, there should be a glass jar with a cork in the top of it, and it is full of glass beads. And as you can see, there are a lot of beads in the jar. And the question is, how many glass beads are there? Well, when it comes to large volumes of objects, trying to count them would be quite tedious. If I assigned one of you to sit down and count every single one of these beads, you probably wouldn't be very happy about that. So is there some other way that we can figure out how many glass beads are in the jar? Well, what if we knew something about the glass beads that we could use to our advantage? What if I gave you this piece of information here, that if we took just 20 of the glass beads, that 20 glass beads has a mass of 4.7 grams. What can we do with that piece of information? Well, since we have a ratio of 4.7 grams for 20 beads, if we were to simplify this ratio, we would end up with 0.235 grams over 1 bead. So that would tell us the mass of a single glass bead in the jar. And if we then took all of the beads that were in that jar and measured their mass and say got a value like 315.7 grams, we could use this value, the mass of either 20 beads or the mass of 1 bead, to give us a factor that we can use to tell us how many beads there are in the jar. So if we know that there is 315.7 grams worth of beads in the jar, okay, and that there is 0.235 grams for every bead in the jar. So we've got our value, how much mass is in the jar. We've got this ratio that relates the mass of a bead to, or the mass of a single bead. If we set this up, gram units cancel out, and we're left with beads over jar. So 315.7 divided by 1 times 1 divided by 0.235. And that calculates out to be 1,343 beads in the jar. So by measuring the mass of just 20 beads and knowing the total mass of all the beads in the jar, we were able to get a count for how many beads were in the jar without having to sit down and count out all 1,343 beads that are in that jar. Do something similar. I've got a bag of popsicle sticks, and I took 20 of those out and got a mass of 28.1 grams for those popsicle sticks. Well, if I take that and do the same kind of process as before, 28.1 grams for 20. I'm just going to put popsicle instead of popsicle sticks. If I take that, I can simplify that ratio and get the mass of just 1. And that comes out to 1.41 grams for 1 popsicle stick. For B here, what is the relative mass of a popsicle stick to a glass bead? Now that we know the mass of a popsicle stick to a glass bead, we can calculate the relative mass of that. In fact, we'll do the relative mass of the glass beads as well. So the masses that we're working with, we have 0.235 grams for one bead, and we have 1.41 grams for one popsicle stick. The smallest value is the one that we typically use when we're calculating relative values. So the smallest value that I have here is 0.235. So that's what I'm going to use to calculate my relative masses. So I'll start with the relative mass of a bead. That came out to 0.235 grams over that tiny value, and no surprise, its relative mass is 1.00. And if we do the same thing for the popsicle stick, spelled that wrong, relative mass for my popsicle stick, 1.41 grams over 0.235. And what do I get for that? 6. So what that tells me is that the popsicle stick is 6 times more massive than a glass bead. Sorry to take a time out there. You probably notice on your handout that it said that the popsicle stick is like 5.9 something times more massive. I must have used a different number of sig figs when I was making the notes. So I changed it to this, so make sure you change that in the first sentence there. So if the relative mass of a popsicle stick is 6.00 as compared to a glass bead, then what would be the mass of an amount of popsicle sticks to the number of glass beads in the jar? Well, let's just go back here. How many glass beads did we end up with? 1,343. So the question wants to know the mass of 1,343 popsicle sticks. Well, we know that the mass of the popsicle, or excuse me, we know that for that many popsicle sticks and that many glass beads, when we had the beads, the mass of all of that was 315.7 grams for 1,343 beads. And since we know that the relative mass is 6, that means that the mass of the same number of popsicle sticks should be 6 times greater. So if we take 315.7 times 6, that gives us 1,894 grams for 1,343 popsicle sticks. Okay. Now, that's one way of doing it. That's one way of using your relative mass value. We also did take the time to figure out the mass of a single popsicle stick. That was 1.41 grams for one popsicle stick. Well, since we know that we have this many popsicle sticks that we want the mass of, it gives us an alternative way to figure it out. We just take the 1343, multiply by 1.41. That gives us 1,894. Hey, it's the exact same value, which we should expect. Okay. So just a couple of examples of how we can use these relative mass values, or how we can count large quantities of things by mass instead of having to actually physically count them out. So your directions for the rest of the hour today. Uh, all you need to do is go onto your Google Drive account, find our lab template folder, and you're going to need a copy of the relative mass lab. So you're going to save and make a copy of that for yourself, which we'll be starting work on Thursday. There's nothing else to do with that. Now, also, unlike other labs that we've done, this one does not, I repeat, does not have a pre-lab test on Edmodo. Okay, it's really more of an activity. We're going to be doing some practice calculations, crunching some numbers based on some measurements we'll make in class on Thursday. But that is it for today. With the rest of class, use it wisely, study on some stuff, work on some stuff. Maybe get together. You can go through some old review materials, old assignments, and start thinking about your final exam for next week.